Hello again. What's this? Your fourth homework assignment? We said we're skipping page 122. Just go right past it. But here's your homework from page 124. These are the word problems. So I'll walk you through these. Then after this, the only thing left is the quiz review, and then we'll be all done. This is looking a smidge small to me, so I'll blow that up. Drop that down. Let's go. It says, in the diagram below, a large flagpole, here it is here, 35 meters high, stands outside of an office building, and Nerissa realizes that when she looks up from the ground, I'm not sure why she's looking up from the ground. Was she lying down on her stomach looking up? Doesn't make much sense, but that's okay. That when she looks up from the ground, when she's 60 meters away from the flagpole, the top of the flagpole lines up perfectly with the top of the building. Okay, great. Flagpole's 35 meters tall. Nerissa is 170 meters from the building. So are the triangles in the diagram similar? Explain. All right. We can say that yes, they definitely are. The easiest explanation would be to say that if this is angle 1 and this is angle 2 and over here is angle 3, and I'm talking about these two triangles here. There's the triangle made by the building, the ground, and then this hypotenuse. Then there's a triangle made by the flagpole, the ground, and this hypotenuse. So we can say angle 1 is congruent to itself. That's a shared angle. And then angle 2 is congruent to angle 3. Because they're both right angles. So the triangles are similar. By angle-angle similarity. So there's your justification. Now that it's justified, we can do the math, and doing the math means that I'd still be pulling these things apart. I've got a base down here of 60 meters, I've got a height of 35. Then to the building, we said the base distance was 170, and the height of the building was unknown. But that means I set up a proportion. These distances along the ground are corresponding, and then the heights are corresponding. So I'll set up one ratio, that's the 60 over 175. 170, I don't know where I got 175 from. And the other one is going to be 35 over each. Again, I see that I can cancel. These are both divisible by 10. So just working with a 6 and a 17 seems a lot easier. But I still need to know what 17 times 35 is. And I don't, so we can use our calculator. 35 times 17 is apparently 595. And that'll be equal to 6 times h. So just divide by 6 now. Those will cancel, and you'll get a height that I guess is a little less than 100. It is 99.16666666666. So you can put the little hat on to mean repeating. These are meters. Do include your units. So instead of using the little hat, if you want to round off, you can, but I usually ask for 2 decimal places. So we could round this off and say it's approximately 99.17, because if we're getting 166, then that second 6 means we round the 6 up to a 7. But they're still meters. But that's it. That's your answer for number 1. Number 2, very similar problem, like basically identical. It looks again like we've got a triangle formed from a flagpole and its shadow and hypotenuse. Then instead of a tall building, we have a tall tree forming a triangle with its shadow and hypotenuse. So it says Malik is standing outside in the sun, and at a certain time of day, a 12-meter tall flagpole casts an 8-meter shadow. So a nearby tree casts a 22-meter shadow. Use similar triangles to determine the height of the tree. So it's almost exactly the same question. We're still going to match up our corresponding parts. So for me, that's the 8 with the 22. And then the height of the flagpole with the height of the tree. So 12 over h. Again, I can reduce. I can at least chop these both in half to just make it 4 with 11. And then if you remember your multiplication tables, then you should know 11 times 12 is 132. And 4 times h is 4h. So just divide by 4. And we'll get what? 2, 3, 33? Yeah, 33 exactly. So it'll be 33 meters is the height of the tree. That's 2. Here's number 3. So number 3 is a little different. The orientation of everything at least is a little different, but it says Katerina's boat has come untied and floated away on the lake. She's standing atop a cliff that's 35 feet above the water. All right. So up here is a cliff. We'll put some grass on it. This must be the edge of the cliff. That should probably be all rocks. Then down here is a lake. So water, 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 water. She stands 10 feet from the edge of the cliff, so she's back a bit, 10 feet. And then she can visually align the top of the cliff with the water at the back of her boat. So all they're saying is her sight line just hits the edge of the cliff and just continues down to the back of the boat. And it says her eye level is 5.5 feet up. So they're basically just saying, not that she's 5.5 feet tall, but her eyes are a little lower than the top of her head, so it's 5.5 feet. So approximately how far out from the cliff is Katerina's boat? So we're solving for the distance from the cliff to the boat. Call it x. Alright, so with these problems, again, you do have to justify whether or not the two triangles are similar. And again, we make a couple of assumptions. We assume that Katerina is standing straight up and down, so she's making a 90-degree angle. And then we assume that the cliff face and the water are forming basically a 90-degree angle. You know, the edge of a cliff can certainly be a little bit slanted, but you know, it's fine. As long as it's close to 90, then we're only approximating the answer anyway. So the next assumption we can make is that the ground is relatively flat. And we know for a fact that water is flat. Water is level. But that means we can take these lines as being parallel. And then the sight line can act like a transversal. So we can say for certain that angle 1 right here and angle 2 right here are congruent because they're corresponding angles. But there would go your argument. So I'm going to label these 1, 2, I guess this will be 3 and 4. So we'll say angle 1 is congruent to angle 2 by the corresponding angles postulate. We'll say 3 is congruent to 4 by the, because all right angles are congruent. Then we can say, therefore, the triangles are similar by angle similarity. All right, now that that's done, now that we know we're similar, we can just solve the problem. And again, we'll solve the problem by pairing up our sides and writing a proportion. So the horizontal distance of 10 here will correspond to the horizontal distance of x that we don't know. And the vertical distance, 5.5, corresponds to the vertical distance, 35. So in go those numbers. We'll put 5.5 in the numerator. We'll put 35 in the denominator. And that means we're going to do 10 in the numerator and x in the denominator. And we're just solving this problem now. So let's just do it. 5.5 times x is 5.5x. And 35 times 10 is 350. So all I got to do is do that division. So we're going to go 350 divided by 5.5. And it's 63.63636363. So just a whole bunch of 63s repeating. So if I were you, I would just give my answer rounded off to 2 decimals. So it would be 63 instead of 63, we use the 6 to round up the 3. We'll say 63.64. And all these measurements are given in feet, so this measurement is also given in feet. So that's it. You know, you'd say something about Katerina's boat has floated 63.64 feet away from the base of the cliff. And then you're done. Number 4 says Brian is photographing the Washington Monument and wonders how tall the monument is. Brian places his 5-foot camera tripod, so his camera is up off the ground by about 5 feet, approximately 300 feet from the base of the monument. So 300 feet, notice, is not the distance all the way to this point on the ground. It's just the distance from the base of the monument to the base of the camera's tripod. It says lying on the ground, he visually aligns the top of the tripod with the top of the monument, and he marks the location on the ground as being 2.7 more feet, 2.75 more feet. So use Brian's measurements to approximate the height of the Washington Monument. Fine. All right. This is another one of those overlapping triangle deals. But the important measurement here would be the total distance, which would be the 300 plus the extra 2.75. And if you know that, then you don't have to redraw the triangles, of course. We're just going to write a proportion, knowing that the height of the monument corresponds to the height of the camera. And we're going to say that the length of this teeny tiny baby triangle corresponds with the total length of the bigger triangle. So it doesn't correspond with the 300. It corresponds with the 302.75. That's going to change our answer, but only slightly. So we'll set this up. I'm going to go 5 over h. Then I'm going to have that equal 2.75 over 302.75. And then let's just bring up the calculator and do this. I can't do any of this math in my head, so we'll show it. Okay, so I got some room for us. 302.75. Times 5 is apparently that much. 1,513.75. And then 2.75 times h. Well, I don't need a calculator for that, do I? 2.75 times h. Alright, so now we're dividing by 2.75. So in our calculator, we just hit divided by 2.75. And there you go. 550.45. And again, if all of these measurements were feet, then this is also feet. And that should be the height of the Washington Monument. So, is that it? Feels like that ought to be it. But it ain't. There's 2 more. Okay, so let's do this river problem. It says a forest ranger needs to measure the distance across a pond from C to D. She knows the measurements between the 2 points shown below. Explain how you know the triangles are similar. I guess we'd have to use these measurements. We've got these congruent angles, but since we don't know x yet, we can't use the 60 with x. We have to use the 48, the 85, the 80. So who goes together? 48 is less than 51, and 80 is less than 85. So those guys go together. And then 51 is the bigger of the two, 85 is the bigger. So just check your division. Again, let's do it in the... Oh, I never took the calculator away. Dum-dum. Did that get in the way of my math? Not really, so that's fine. I'm glad I still have the calculator because now I need it. So let's check and see. When I'm clicking on the wrong thing. All right, so when I do 51 divided by 85, I get 0.6. When I do 48 divided by 80, I get 0.6. So with the sides proportional and with the vertical angles in the middle to boot, we know that our triangles are similar by side angle side. So we can make that argument for part A. So we can say by side angle side. So super obviously, if you say this, you're not getting credit. The work that you must show is to actually justify everything you've done. So you have to show that the 48 over 80 equals 0.6. You have to show that the 51 over 85 equals 0.6. And you got to make a note about how angle 1 is congruent to angle 2 by vertical angles theorem. So now you justified it. So now when they ask for the distance from C to D, we can just set up a proportion and solve it. So certainly one of our ratios is going to be the x divided by the 60. The other proportion is going to be either the blue over the blue or the orange over the orange, and it doesn't matter. I'm going to go with the 80 over 48. And of course, since these are both divisible by certainly 8, divide by 8 you get 10, divide by 8 you get 6. You can even divide again by 2, and you get 5 over 3. So using 5 over 3 as our ratio is going to be a little bit cleaner. We get 3 times x for 3x. We get 60 times 5 for 300. So that means x is 100. And these are all marked in meters. So that must be 100 meters. Which means this lake, pond, it's a pond I guess, is 100 meters wide. Alright, that's it. So the last one, it says a surveyor needs to determine the distance across the base of a mountain, so distance from A to B. The surveyor can directly measure the lengths given below. So he can directly measure these distances, but for some reason he can't measure these distances. I don't know why not. Let's just give him the benefit of the doubt though. Are these triangles similar? Justify your answer. Well, these angles being congruent is given, and then the vertical angles are there too. So we're going to say it's by angle similarity. And we should probably prove it. So you'll tell me how angle B is congruent to angle D because it's given. And you'll tell me how angle 1 is congruent to angle 2 by the vertical angles theorem, which is angle 1 and 2. Make sure you label them in the diagram before you talk about them. All right, so now that we know for a fact we're similar, we can solve for whatever we want by setting up proportions. So the distance we're after is AB, so we'll call that x. That corresponds with the 720, so one of our ratios should be x over 720. The other ratio should be whatever other pair of sides we have. X is from the bigger triangle, so make sure you put the 840 in the numerator too, and divide that by 420. We could reduce a whole bunch if you wanted to, but let's just not even bother. You're going to get 420x, and that's going to equal whatever 840 times 720 is. But you know what? We've got calculators, so we can do this. Move it over here. Okay, and I think I said that we wanted to do 720 times 840, which is 604,800. But we have a calculator, so none of this math is hard. Now you just divide by 420. And you get 1,440. And all the measurements are in feet. So that should be in feet as well. All right, I think that's it. So that's it for all your homework from the packet. I probably need to take a break for a while, be with my kids again. They're up from their nap. But later when they go to bed at about 8, sometime between 8 and 9, I'll put up the answer key for the review packet, the review guide. If I have it. I might not have it. If I don't have it, you guys might have to wait for it until tomorrow. Anyway, I hope this was helpful. If it was helpful, could you say so? If this helped you, then mention it in class. Just say, hey, Mr. F, that was really useful. This takes a lot of time for me to do, and I wonder if it's worth it. So if you want me to keep doing it, you better tell me that yes, it's worth it. All right, I'll see ya. Bye.